Welcome everyone. This is the second video in the series of linear differential equation, and in this video I am going to talk about the process of solving homogeneous linear differential equation with constant coefficient. I will be doing a huge number of problems, so this will be a long video and all kind of problems will be discussed. So to get a better idea of the things, you need to watch the video till the very end, right? So let's start. What is the process of solving a linear differential equation? The process is very simple. First look at it and then we will explain through many examples. So the first step is to write the auxiliary equation. What is this auxiliary equation? I will tell you. The second step is to find the roots of the auxiliary equation, and in the third step we look at the roots. Roots may be real and distinct, so in that case we write the solution in a very specific way that I will explain. Second possibility is that roots may be real and equal, so how to write the solution in that case, that we are going to discuss. And when the roots will be complex, then how to write the solution, that we will be discussing. Okay, so let us directly go to the problem solving, because problems are the best way to understand any concept. So I am going to first discuss the possibilities when the roots are real and distinct. So suppose we have a differential equation which is given, and before I solve this differential equation, I want to highlight certain important terms. That this is one way of writing the differential equation, where y double prime or y double dash, the right way is that y double prime, but I call it y double dash because that is my habit. So you just understand it, that by y double dash what we mean is the second order derivative of y with respect to the suitable independent variable. Then y dash is the first order derivative of y. So first of all, be clear about the notation. This differential equation is nothing but d2y by dx square minus dy by dx and minus 6y is equal to 0, right? And we also follow a notation where we can replace this d by dx, the differential operator, by the notation capital D. So in that sense this differential equation will become what? This here if I have d2 by dx square, we replace it by d square. If we have d3 by dx cube, we replace it by d cube, right? And so on. I hope you have got the sense. So what it will become? It will become d square y minus dy minus 6y is equal to 0, which in turn can also be written as d square minus d minus 6y is equal to 0. So either the problem may be given in this form, or the problem may be written in this form, or the problem may be written in this form. In all the cases we should be clear that what it is representing. So now what is the process? The process of solution is that first of all we write the auxiliary equation. So how to write the auxiliary equation? To write the auxiliary equation, the process is very simple. Let me write it. The auxiliary equation is given by, and from here onwards I will be writing auxiliary equation just by writing AE. So to write the auxiliary equation, what you do, you replace d2y by dx square by the term m square. You replace the dy by dx by m, and here you have just y, so you just leave the constant term. So basically what is the process that we are following? Let me explain it one more time. If we have d by dx or first order derivative, if we have dy by dx, we can replace that term by m. If we have the second order derivative, that is d2y by dx square, we replace that by m square. If we have the third order derivative, d3y by dx cube, we replaced by m cube. And I hope you have got the drift, that if it is fourth order derivative, we replace it by m4 and so on. Here there is no derivative, so we just write the constant term. So for this, what will be the auxiliary equation? For y double dash I will write m square For y dash I will write minus m, and here there is no derivative of y, so I'm just writing minus 6, the constant term, the coefficient of y, and this is equal to 0. So this equation is known as the auxiliary equation. Before I solve this question, I want to quickly also write the auxiliary equation corresponding to this differential equation, and you pause the video and try to write that what it will be. So if I write it for y double dash, I will be writing m square, minus 4 is there, and for y dash I will write m, and for y there is no need to write anything, but just we write the constant term, that is minus 12 is equal to 0. So basically what we are doing, we are considering that since I am not differentiating y, we are writing basically m to the power no derivative of y, means m to the power 0. If I am writing first order derivative of y, m to the power 1. If I am writing second order derivative of y, m square, right? So this is how it should be understood. Now this is the first step, writing the auxiliary equation. What is the next step? Next step is to find the roots of the auxiliary equation. So how do you find the roots? This is a quadratic equation, so to solve it I am factorizing m square minus 3m plus 2m minus 6 is equal to 0. So if I factorize it further, m common m minus 3 plus 2 common m minus 3 is equal to 0, right? So I will get m minus 3 into m plus 2 is equal to 0, right? So this will give me the roots, that is m is equal to 3 and minus 2. Okay, now once we have got the root, the first thing that I want all of you to note that these two roots are real roots, right? They are real roots and they are distinct root. For a quadratic equation, the roots may be real, distinct, roots may be imaginary or complex, or the roots may be equal also. I will be discussing them one by one. So when the roots are real and distinct, in that case how do we write the solution? So just look at this thing, that when roots of an auxiliary equations are like m1 comma m2 comma m3, if I am talking about an nth order differential equation, if it is mn, then the solution will be written as y is equal to c1 e to the power m1x plus c2 e to the power m2x and up to cn e to the power mnx. And I hope most of you might already have noted that if we are solving a differential equation of order n, then its auxiliary equation will be of degree 2 polynomial. So if you see that this is a differential equation of order 2, I hope because if you are watching this video, I expect that you know how to find the order and degree of a differential equation. Since we are talking about linear differential equation, the linear differential equation will always have the degree 1, and order is the highest order derivative that is occurring in the differential equation. So here it is the second order differential equation. So the second order differential equation will have its auxiliary equation of degree 2 polynomial. So this is a degree 2 polynomial. So how many roots it will have? It will have 2 roots, right? And these two are distinct. So how the solution should be written? As we have just seen that the solution is, I will be writing the solution, and let me change the color. So there will be two arbitrary constant in the solution. So first arbitrary constant will be c1 and m1. Here the first root is 3, so I will write e to the power 3x plus c2, and the second root is minus 2, so I will write e to the power minus 2x. So this is the solution of this linear differential equation. Very simple process. Now again I repeat, what are the important things that you need to keep in mind? The first is that this is an order 2 equation, so its auxiliary equation should have 2 roots. Second is that the general solution, this is called the general solution, and it will contain two arbitrary constant, that is c1 and c2. So this is the way the general solution is written. Okay, so this is the first problem. Now let us solve the second problem, that is 1b. Okay, so to solve this problem we have to follow the same process. So what is the step number 1? The auxiliary equation is, I am solving the question number 1b, right? So the auxiliary equation is y double dash, so it is m square minus 4y dash, so 4m and minus 12. There is no derivative of y, so m to the power 0, which we are not writing, so that is equal to 0. Now it was an order 2 equation, so the auxiliary equation I have got is a equation of degree 2, or it is a polynomial of degree 2. Now we have to find the root. So how do you find the root? You write m square minus 6m plus 2m minus 12 is equal to 0. So the next is we will take m common, so m into m minus 6 plus 2 into m minus 6 is equal to 0. So what did I get? I will factorize it. M minus 6 into m plus 2 is equal to 0. So the solution, this will give me the root, that is m is equal to 6 and minus 2. So we have noted that the roots are all real, means there are two roots and both are distinct also. So how do you write the solution? You know the general form, that you write c1 e to the power m1x plus c2 e to the power m2x. So here I write c1 e to the power, the first root is 6, so I will write c1 e to the power 6x plus c2 e to the power minus 2x. So this is the solution. Very simple process. I hope you have understood it. So we are going to solve some more problem. Now if you look at this problem here, along with solving this, there are two more conditions, or there are two conditions which are also given, that is y0 or y0 is equal to 1 and y dash or y prime 0 is equal to 3. These two conditions are given at the same point, that is x is equal to 0. So this problem is also known as initial value problem, and when we have to solve it, we are going to use these two conditions to get the value of the arbitrary constant. So here in this solution that I have got two arbitrary constant, and I hope you have already understood that in any general solution of a differential equation of order n, the solution will contain n arbitrary constant. I repeat it, if there is a differential equation of order n, then its general solution must contain n arbitrary constant. So how can we solve this problem? So to solve this problem, we have to start the same way. We write the auxiliary equation. So the auxiliary equation will be 4m square minus 8m plus 3 is equal to 0. I hope you got it. For y double dash, m square for y dash m, and there is 3y, so I just write the constant term 3. We don't write anything for y. If there is a y term, we write the coefficient of y. Now we have to factorize. So here you have 4m square into 3, so 12m square. So how will you factorize? 6m square, 4m square minus 6m and minus 2m plus 3, that is equal to 0. Moving forward, I can take 2m common, so I will get 2m minus 3, and I can take minus 1 common, I will get 2m minus 3 is equal to 0. So from this I can take 2m minus 3 common, and I get 2m minus 1 is equal to 0. So I get what? I get m is equal to 3 by 2 and m is equal to 1 by 2. So we have got two roots, and both of them are real and distinct. So what will be the general solution? The general solution will be given by y is equal to c1 e to the power 3 by 2x in place of m1, and c2 e to the power 1 by 2x. Right. Let me call this equation number 1. Now if these two conditions are not given, this will be the general solution, but since these two conditions are given, we have to eliminate, or we have to get the values of c1 and c2 using these two conditions, right? So how do you use this condition? It is given that y0 is equal to 1. So basically what does this mean? It means that if I take x is equal to 0, in this I will get y is equal to 1. So I will take c1 and e to the power 0, e to the power 0, it will, let me write it, e to the power 3 by 2 into 0, so it will be 0, and plus c2 e to the power 1 by 2 into 0, because I am taking the x value 0, so it will also be 0, and it is given to be 1. So basically what is given, it is e to the power 0 is 1, so I get c1 plus c2 is equal to 1. And we have to use this condition y dash 0 or y dash at the value 0 is equal to 3. So to use this, first of all I have to differentiate this. So to get y dash means what? I hope you are clear that y dash is dy by dx. So if I differentiate, I will get c1, and what I will get? I will get 3 by 2 e to the power 3 by 2x, and c2 1 by 2 e to the power 1 by 2x. Okay, and it is given that y dash 0 is equal to 3. So it will give me what? I am continuing here in this side. So if I put in this, if I put 0, I will get c1 and e to the power c1 into 3 by 2. So I will get 3 c1 by 2. And if I put this, it will become 0. 3 by 2 into 0 will be 0, so e to the power 0 is 1. So I'm not writing that. And here I am writing c2 by 2, and this will also become 1. So this is equal to 3. So basically, if you simplify, you will get 3c1 plus c2 is equal to 2 into 3 is equal to 6. Now this, if I call this equation as equation number 2 and this as equation number 3, what is the next thing that we have to do? The next thing that we have to do is to solve these two equations, right? So how to solve these two equations? To solve these two equations, the first one is c1 plus c2 is equal to 1, and second one is 3c1 plus c2 is equal to 6, right? So we subtract them. So this is minus, this is minus, this is minus. So c2 and c2 will cancel. Can I write here? There is no space. So c1 minus 3c1, that is minus 2c1. And 1 minus 6, that is minus 5. So c1 value I got is 5 by 2. And what is the c2 value I will get? c1 plus c2 is equal to 1. So c2 is equal to 1 minus c1. So 1 minus 5 by 2. So that is equal to minus 3 by 2. So I have got the value of c1 and c2. Now what is the this equation, how this equation will change? So in place of c1 I have to write 5 by 2, and in place of c2 I have to write what you call minus 3 by 2. So there is no space in the bottom, so I am writing the final solution here, that is y is equal to, in place of c1 I am writing 5 by 2 and e to the power 3 by 2x, and minus c2 is 3 by 2, because it is plus, so it is minus 3 by 2. So minus 3 by 2 and e to the power 1 by 2x. So this is the general solution. I write it again here because it is kind of slightly clumsy. So I am writing here 5 by 2 e to the power 3 by 2x minus 3 by 2 e to the power 1 by 2x. So this solution is also known as the particular solution, because we have obtained this solution with the help of general solution. This is known as general solution, and what we have got is the particular solution. And since we wanted to get two value c1 and c2, so we require two condition. If we are solving a order 3 equation, so its general solution will contain 3 arbitrary constant, and in that case you require 3 conditions. Okay, so I hope you are getting. So let us move to the next problem. And here we have taken a higher order problem, means the problem of order 3. So its auxiliary equation will be a polynomial of degree 3. So how to solve it? So the first step is the auxiliary equation is. So what is the auxiliary equation? M cube minus 2m square minus 5m plus 6 is equal to 0, right? And this is a cubic equation. So how can we find the roots of a cubic equation? So to find the root, we are going to use the hit and trial method. So what is the hit and trial method? I will start with the root m is equal to 1, and I will check whether it will satisfy this equation. So if I take m is equal to 1, I will get 1 minus 2 minus 5 plus 6. So we got what? 7 minus 7 is equal to 0. So we noted that m is equal to 1. So m is equal to 1 is a root, let me call this equation 1, is a root of equation 1 Now this is a cubic equation, so how many roots it will have? It will have 3 roots, and 1 root I already have got. So now you can do the division. I hope you know how to find the other roots. Since this is the first problem, I am going to do it. M cube minus 2m square minus 5m plus 6. So you can either directly factorize it. First let me do it directly. So here m is equal to 1 is a root. It means that m minus 1 is a factor of this. This is known as factor theorem. You have studied this in your school, that if m is equal to 1 is a root, then m minus 1 will be a factor. So how will you factorize it? I can write this thing as m square into m minus 1. And look at this carefully. We know that m minus 1 is a factor, so we just wrote m minus 1, but we want m cube, so I need to multiply it by m square. Now it is m cube, and m square minus 1 is minus m square, but we want minus 2m square, so we need minus m square extra, so I will write minus m into m minus 1. So now you can see that it will become minus m square and minus m square from here, so I will get minus 2m square. But this will give me what? This will give me minus m and minus 1, so plus m. But we want minus 5m, so means we need minus 6m extra. So for that I write minus 6 into m minus 1, right? And so we got m minus 1 into m square minus m minus 6. So we can further factorize it, that is m minus 1, and this is a quadratic equation, so m square minus 3m plus 2m minus 6. So this will give me what? This will give me m minus 1, and here I can take m common, m minus 3 plus 2 common, m minus 3. Okay, so I got m minus 1 into m minus 3 into m plus 2, right? And we have to equate it to 0. So if I equate it to 0 means what? We could have written that as well. So let me write it 0 here and make it an equation like this. So we don't have to write it again. So this is equal to 0, 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 this is equal to 0. So I got m is equal to 1. From this I will get minus 2, and from this I will get 3. So all of them are real and they are not equal, means they are distinct. So the solution will be written as, now it has 3 arbitrary constants, c1 e to the power 1x, so I write x, c2 e to the power minus 2x, so I write minus 2x, and c3 e to the power 3x, so I write 3x. So this is how we write the general solution. For those students, in case if you have not understood that how did I factorize it, after this step where you have got m minus 1 as a factor, you can divide the whole expression m cube minus 2m square minus 5m plus 6 by this factor m minus 1. So to divide it, first you take m square, it will become m cube minus m square, then you subtract, it will become plus, it will become minus, you can cancel, you will get minus m square minus 5m plus 6. How much you require now? You require minus m, so you require it will become minus m square and plus m. So now you subtract minus plus, so this term will cancel, so it will become minus 6m plus 6. So I will take how much? I will take minus 6, so I will get minus 6m plus 6, and when I subtract finally I will get what? 0. So this will be cancelled, this will cancel, so I will get 0. So you see that this thing can be written as m minus 1 into m square minus m minus 6. So here I have already done it, but in case if you are comfortable with this process, you can write directly. In case if you are not, you can do the division and write the factorization. Okay, moving ahead, we have an equation of order 4, right? So I am going to quickly solve it, and as I told you that we are going to take lot of problems, so this video will be a long video and you need to watch till the very end because everything will be summarized in just one video. So for linear differential equation, I have uploaded one, and this is the second video, and it will cover almost all the unit. Okay, so now if I write the auxiliary equation, what will be the auxiliary equation? The auxiliary equation is m to the power, it is fourth order derivative, y to the power 4. So m4 minus 5m square plus 4 is equal to 0. Now we have to factorize it. So how can we factorize? See, this is a this can be seen as a biquadratic equation, because m square a square, so I can write it m to the power 4. If I multiply these two terms, it will be 4m to the power 4, so I can write it 4m square minus m square, right? I hope you understood what I did. Now here you can see minus 5m square, and the property like minus 4m square into minus m square is 4m to the power 4. So it is the correct factorization. I can take m square common, so I will get m square minus 4. I can take minus 1 common, so I will get m square minus 4 is equal to 0. Okay, and now I have m square minus 4 into m square minus 1 is equal to 0. So m square minus 4 can be factorized. It can be written as m plus 2 into m minus 2. It can be written as m plus 1 into m minus 1. So we have got 4 roots. What are the values of m? The values of m are minus 1, 1, minus 2 and 2. So these are 4 roots, but they are all real and distinct. So we can write the solution easily: c1 e to the power minus x plus c2 e to the power x plus c3 e to the power minus 2x plus c4 e to the power 2x. So the differential equation was of order 4. Its general solution contains 4 arbitrary constant. Keep this in mind. The order of a differential equation helps you to count the number of arbitrary constant in the general solution as well. Moving ahead, we are going to now talk about those differential equation where the roots are real and equal. Right. So when the roots are real and equal, suppose we have a situation where there are two roots m1 and m2 of a second order linear differential equation, and its auxiliary equation has two roots m1 and m2, and suppose they are both equal, to m. So in that case, how the solution is written? We can't write the solution c1 e to the power m1x plus c2 e to the power m2x, or because both of them are equal to m, so we can't write them c1 e to the power mx and c2 e to the power mx. If I write that, what will be the problem? The problem will be that you can rewrite it as c1 plus c2 e to the power mx, right? So you will have just one arbitrary constant, that is c e to the power mx. Because there is a this is a differential equation of order 2, so it should have two linearly independent solution. In case if you have watched my previous video, you might be able to understand this. So now the question is that if I can't write it like this, if this is wrong, then what should I do? Then in that case, the process is that if you have roots like m1, m2 and both of them are equal to m, so you write the general solution as c1 plus c2x e to the power mx, right? If you have three roots like m1, both the roots, all the three roots m1, m2, m3, and if they are equal to m, then in that case we will write the general solution as c1 plus c2x plus c2x square e to the power mx. And now I hope you have got the drift, that if I have m1 is equal to m2 is equal to m3 is equal to m4 and all of them are equal to m, in that case the general solution will look like c1 plus c2x plus c3x square plus c4x cube and into e to the power mx. Okay. So once we have understood the process, let us quickly solve few questions. So to start with, I am taking a second order linear differential equation. So what will be the auxiliary equation? The auxiliary equation is 4m square plus 4m plus 1 is equal to 0. So this will give me what? You can see, you can factorize it easily, but I can clearly see that this is 2m plus 1 whole square is equal to 0. Right. Now don't make the mistake of writing the root as m is equal to minus 1 by 2. You have two roots which are minus 1 by 2 and minus 1 by 2. They are repeated roots. You could have even done the factorization also, in case if you are finding it difficult. You could have written it 4m square. Don't write both the things. I'm just writing the alternate way. 4m can be written as 2m plus 2m plus 1 is equal to 0. So here you will get what? You will get 2m common. So you will get 2m plus 1. From this also you will get 1 common. You will get 2m plus 1 is equal to 0. So you will get what? You will get 2m plus 1 into 2m plus 1 is equal to 0. So m is equal to minus 1 by 2 and minus 1 by 2. So either you do it like this or do it like this. So this is an alternate part. So I'm changing the color again. So now we have got the roots which are equal. So how will I write the solution? As I have told you that the roots are equal, so then I will write the solution as c1 plus c2 into x e to the power minus 1 by 2x. Right. So basically when we write the solution like this, we have two solutions, that is e to the power minus 1 by 2x and x into e to the power minus 1 by 2x, and I am writing their linear combination. So this can be actually seen as c1 e to the power minus half x plus c2 and x e to the power minus half x. So these two basically are the solution which are linearly independent, and they will form the basis for this solution with this differential equation. Basis will have e to the power minus 1 by 2x and x e to the power minus 1 by 2x. So did you notice one point, that if the root is repeated one time, we are getting x into the multiple of e to the power minus root time the x, right? Let me move to the next problem to illustrate the things better. And here again we have an initial value problem. So I will actually solve the problem to find the general solution, and initial value problem part I will leave for you, and you must have to answer that in the comment section, right? Because that will help me to understand that whether you are understanding it or not. So what will be the auxiliary equation, ladies and gentlemen? The auxiliary equation is m square plus 6m plus 9 is equal to 0. And how many of you can see that this is nothing but m plus 3 whole square is equal to 0? A square m square plus b square 9, 2ab, 2 into m into 3. So we get the roots like m is equal to minus 3 and minus 3. Don't make the mistake of writing just minus 3. You have a degree 2 polynomial here, so it should be having two roots. The roots should be 2. Of course they are repeated, but they are counted as two roots. So what will be the general solution? General solution will be c1 and c2 into x e to the power minus 3x. Now consider this as equation 1 and use these two conditions, y naught is equal to 2 and y dash naught is equal to 3, as I have shown you in one of the previous problem, and let me know that what is the particular solution. So this is one of your exercise. Let me know in the comment section. So particular solution, comment, right? Moving forward, I am going to take a third ordered linear differential equation. So if I take a third ordered linear differential equation, first of all, what is the auxiliary equation? The auxiliary equation is y triple dash, so it will be m cube minus 3y dash, so it will be minus 3m, and minus 2 is equal to 0. There is no y double dash term here. I hope you have noted. I am writing m cube minus 3m minus 2 is equal to 0. Okay. So how to factorize it? So if it is a cubic equation, again we are going to use hit and trial method. So if you put m is equal to 1 minus 3 minus 2, that will not be equal to 0. But if you try m is equal to minus 1, you will not what? Minus 1 cube, that is minus 1. Minus 3 into minus 1 and minus 2. So how much we get? We get minus 1 plus 3 minus 2, so that is equal to 0. So m is equal to minus 1 is a root, so m plus 1 is a factor, and I have explained to you that either now you can divide this by m plus 1 or you can directly write the factorization. So I am writing m cube minus 3m minus 2 is equal to 0. So here we can write m into m plus 1, not m into m plus 1, sorry, m square into m plus 1, because we want m cube. Now if you look at this term, I will get m square if I multiply m square into 1, and we don't have m square term here, so I need to write minus m square. So I write minus m into m plus 1. So you see, I will get minus m square and plus m square, that will cancel. Now I will have minus m, but it is minus 3m, so we need minus 2m extra, so I will write minus 2 into m plus 1. Now you can clearly see that it will be nothing but this. So what is the factor here? Factor is m plus 1 into m square minus m minus 2 is equal to 0. So this will give me what? This will give me m plus 1, and m square minus m can be written as minus 2m plus m minus 2 is equal to 0. So this will give me m plus 1, and m can be taken common, so m minus 2 plus 1 can again be taken common, m minus 2, and that is equal to 0, right? So basically we are getting two roots, m plus 1, m plus 1 and m minus 2, right? So the roots are m is equal to minus 1 and 2. So there are three roots, out of which two are repeated root and one is a distinct root. So how will I write the general solution? So for these two roots minus 1 and 1, I will write the solution as c1 plus c2x and e to the power minus x, and for the third root I will write c3 e to the power 2x. So this is the general solution corresponding to this linear differential equation. Okay. Solve one more problem which is of order 3. Solving more problems is important. What is the auxiliary equation? Ladies and gentlemen, the auxiliary equation is here I can write 8m cube minus 12, and I hope by now you are very much confident about how to write the auxiliary equation. So m cube minus 12m square plus 6m minus 1 is equal to 0. I suggest you to pause the video and calculate the roots yourself, because that is very important. So let's do it. Pause, start. So how to factorize? If you look at this very carefully, you can see this is 2m cube minus 3 into 2m whole square into 1 plus 3 into 2m into 1 square minus 1 cube. Do you know the formula of a minus b whole cube? It is a cube minus 3a square b plus 3ab square minus b cube. So I just have tried to write the whole expression in that form. So this will become 2m. In place of a we have 2m, in place of b we have 1. So 2m minus 1 whole cube is equal to 0, and this will give me 3 roots, that is m is equal to 1 by 2, m is equal to 1 by 2, m is equal to 1 by 2. I hope you realize that basically there are 3 factors here. It is 2 minus 1 into 2 minus 1 into 2 minus 1. Some students do make the mistake of just writing m is equal to 1 by 2 and then they get the wrong answer, means they get the 0 marks, because here the roots are repeated and it is coming 3 times. So what will be the general solution? I will write c1 plus c2x, and the root is repeated 3 times, so I will write c3x square e to the power 1 by 2x. So this is how we write the general solution. Okay, now the next thing we are going to discuss is what if the roots are complex roots. So if the roots are complex, one thing everyone knows, and I hope you also know, that whenever the complex roots are there, the complex root always come in pair. So if alpha plus I beta is a root, then alpha minus I beta should also be a root. It can never happen that just one of the root is there and this root is not there. This is a property of quadratic polynomial or any equation, that complex roots always, or complex number roots always come in pair, right? So if suppose one of the pair of roots is alpha plus minus iota beta, right? So in this case, how the solution is written? Solution is written as e to the power alpha x into c1 cos beta x plus c2 sine beta x. Some of you might be thinking that how this is written. For this also there is an explanation, we can discuss that, but I am not going into that detail, otherwise it will become too lengthy, right? So I am just focused on solving the problem, right? So if the equations have the roots like alpha plus minus I beta, the general solution will be like this. For example, if there is an auxiliary equation whose roots are 2 plus minus 3i, so what is alpha? Alpha is 2, beta is 3. So for that I will write the general solution as e to the power 2x and c1 cos beta, so beta is 3, so c1 cos 3x plus c2 sine 3x. Okay, so if you have understood this, let us do some problem solving, as problems makes the man perfect. Very popular. So ladies and gentlemen, how to solve this differential equation? So first write the auxiliary equation. So the auxiliary equation is m square plus 2m plus 2 is equal to 0. Okay, I hope you are still there. So I have to find the roots. How to find the roots? If you try to factorize it, 2m square, you can't break 2m square to get 2m to get 2m square. So in this case we are going to find the roots by using the very popular result. You remember minus b plus minus under root b square minus 4ac by 2a. We all studied this in class 7th or 8th standard, and also in class 12 we have studied about quadratic equation. So what will be m? M is equal to minus b. What is b here? 2. So minus 2 plus minus b square. So that is 2a square minus 4 into 1 into 2 divided by 2 into 1. So what did I get? I get minus 2 plus minus 4 minus 8. So 4 minus 8 is minus 4 by 2. So I got minus 2 plus minus 2i by 2. So this is giving me what? This is giving me minus 1 plus minus I. So if I have to compare it, what is alpha here? Just for your convenience, alpha is minus 1, and what is beta? Beta is 1. The coefficient of I means we are comparing this thing with alpha plus minus I beta. So you can see in place of alpha we have minus 1, in place of beta we have 1. So what will be the general solution? General solution will be e to the power minus alpha x, that is e to the power minus x, and c1 cos beta x, so beta is also 1, so c1 cos x plus c2 sin x. Okay, basically just to highlight this thing, if you ask me that what is the fundamental solution for this differential equation, so actually the solution y can also be seen as c1 e to the power minus x cos x. So this is one of the solution, and plus c2 e to the power minus x sin x. So this is another solution, and the general solution has been written by taking the linear combination of this solution and this solution. So this is called as the general solution. Okay, I hope up to this everything is perfectly fine. So okay, how to solve this linear differential equation? The process is same. What is the auxiliary equation? The auxiliary equation is m square plus 4m plus 13 is equal to 0. Now I'm not going to talk about the details, so I hope you can understand now. So m is equal to minus b, so minus 4 plus minus b square, so that is 16 minus 4 into a into c. So a is 1, c is 13, so 4 into 13 is 52 divided by 2a, so 2. So that will give me what? That will give me minus 4 plus minus under root minus 36 by 2. Okay, so that is basically what? Minus 4 plus minus under root minus 36 is 6 iota by 2. So we have got the roots. M is equal to minus 2 plus minus 3i. The red looks better. What do you think? Give your opinion, black or red. So if I write the general solution, y is equal to alpha. Alpha is minus 2, so e to the power minus 2x, e to the power minus alpha x, c1. Beta is 3, so c1 cos 3x plus c2 sin 3x. So this is the general solution. No discussion further. Move ahead. The differential equation here is of order 4. So what is the auxiliary equation? The auxiliary equation is m4 plus 5m square plus 4 is equal to 0. How to factorize this? You are all very smart now. So m to the power 4 plus 4m square plus m square plus 4 is equal to 0. So m square can be taken common. I can write m square plus 4. I can take 1 common. I can write m square plus 4 is equal to 0. So I am expecting 4 roots because order of the differential equation is 4. So m square plus 4 into m square plus 1 is equal to 0. So this factor will give me m is equal to plus minus 2 iota, and this factor will give me m is equal to plus minus iota. So we have got two pairs of imaginary root. How should I write the solution? In both the pairs the alpha is equal to 0, because if you write plus minus 2i, this can be seen as 0 plus minus 2i. So if I write it for this particular pair of root, I should write the solution as e to the power 0x c1 cos beta, so c1 cos 2x plus c2 sin 2x. And for this pair of imaginary roots, I would write e to the power 0x and c3, because c1 and c2 constant I already have used, c3 cos x plus c4 sin x. because there are two imaginary pairs, so there will be two parts. So this part corresponds to this pair of solution, and this part corresponds to this pair of solution. I hope you also have seen that plus minus iota can be seen as 0 plus minus iota. So just for make it look better, e to the power 0x can be 1. So I will write the solution c1 cos 2x plus c2 sin 2x, and there it will be c3 cos x plus c4 sin x. So there are four linearly independent solutions: cos 2x, sin 2x, cos x, and sin x. Okay. Okay, last problem in this category, and then I'm going to take some very interesting problems. So if you are still there, please be till the very end, because I will also be talking about what if the roots, or what if the particular solution are given, and then how to find the differential equation, so the reverse process. So before that, let me quickly solve this problem as well. So by now you are all very clear, I'm not writing that. So what is the auxiliary equation? The auxiliary equation is y4, so m4, y double dash, so m square, and just y, so the constant term, that is 256, is equal to 0. Right. Now how do you factorize this differential equation? So this is very obvious. I don't know how many of you can see. Just pause the video, but I am writing for your convenience. M4 can be seen as m square square, and 256 can be seen as 16 square, and this term 32 m square can be seen as 2 into m square into 16. So that is equal to 0. So this is basically a square plus 2ab plus b square. So a square in place of a square, in place of a, basically, sorry, in place of a we have m square, and in place of b we have 16. So this whole square is equal to 0. So basically there are two factors, and here students may make a lot of mistake. Don't make the mistake, right? Be clear. Here the order is 4. The degree of this polynomial is 4, so there must be 4 roots. So there are two pairs, m square plus 16 and m square plus 16. The first, this first bracket or the first factor will give me m is equal to plus minus 4i, and this will also give me m is equal to plus minus 4i. So when we get this pair of imaginary roots, how do you write the solution? So just to quickly give you the general idea, when we have the roots like alpha plus minus iota beta and alpha plus minus iota beta, when we have two pair of imaginary root, we write the general solution as e to the power alpha x, because alpha is common in both. And then here we write c1 plus c2x cos beta x and plus c3 plus c4x sin beta x. I hope you must have got the drift, that what if there are three pairs of imaginary root, alpha plus minus I beta, alpha plus minus I beta, and alpha plus minus I beta. Then the solution will be e to the power alpha x, and here it will be c1 plus c2x plus c3 x square cos beta x, and plus c4 plus c5x plus c6x square sin beta x. The number of arbitrary constant will be 6. So in this problem we have got two pairs of imaginary root, plus minus 4i and plus minus 4i. There is no space in the bottom, so I am writing the solution here. So the general solution will be given by alpha is 0, right? Alpha is 0 because 0 plus minus 4i, 0 plus minus 4i. So the solution will be e to the power 0x, right? And e to the power 0x, let me write it so that you don't miss. And then c1 plus c2, c1 plus c2 x, sorry, c1 plus c2 x and cos 4x, and plus c3 plus c4x sin 4x. Okay, so just to make it look better, let me write the solution one more time. So y is equal to it has become very thin, ladies and gentlemen. So y is equal to it will be 1, so I write c1 plus c2x cos 4x plus c3 plus c4x sin 4x. So this is the general solution. I have just rewritten it to make it look better. Okay, now moving ahead, we are done with three category of possibilities, three possibilities rather. One, when the roots are all real and distinct, when the roots are repeated, and when the roots are imaginary or complex number. There may be possibilities in which some of the roots may be real, some of the roots may be repeated, some of the roots may be imaginary. We are going to look at those kind of problems also, but in this I'm moving ahead with the next kind of problem. So this kind of problems may also be asked in the exam, that here they are asking you to find a differential equation of the form ay double dash plus by dash plus cy is equal to 0 for which following functions are the solution. So now they have given you the solution and they are asking you the differential equation corresponding to that. So let me quickly solve each of them one by one. So I am solving the first part. So it is given that it has one of the solution as e to the power 3x, another solution is e to the power minus 2x. So if we have a solution e to the power 3x, how do we get the in the solution, how do we get e to the power 3x if we have the root that is equal to 3? So e to the power 3x is coming because one of the root must be equal to 3. And e to the power minus 2x will be the solution because one of the root must be equal to minus 2. So you know the roots now of the auxiliary equation. So what will be the auxiliary equation? The auxiliary equation will be, the auxiliary equation is m minus 3 because you want to get the root 3 and you want to get the root minus 2, so the next factor will be m plus 2 is equal to 0. So this will give you what? This will give you m square minus 3m and plus 2m. So minus 3m and plus 2m and minus 6 is equal to 0. So this will give me m square minus m minus 6 is equal to 0. Now if this is your auxiliary equation, then what will be your differential equation? Can you guess? So the differential equation will be, for m square I need to write y double dash. Now I am changing the process. When we had y double dash I was writing m square, but when we have m square I am writing y double dash because we want to get the differential equation. For m we have to write y dash and it is minus 6, so I will write minus 6y is equal to 0. So this is the answer of the first problem, that the differential equation is in the form of ay double dash plus by dash plus cy, where a is 1, b is minus 1 and c is minus 6. So this is the solution of the first problem. If I look at the second problem, the solutions are 1 and e to the power minus 2x. So can you pause the video and tell me that what will be the roots? If you are getting 1 at the solution, basically 1 can be seen as e to the power 0x, right? And then other solution is e to the power minus 2x. If it is 1, means the solution should be e to the power 0x and then e to the power minus 2x. So it means what? That the roots will be 0. The roots m will be 0 and minus 2. So if the roots are 0 and minus 2, then what will be the auxiliary equation? Auxiliary equation will be m minus 0 into m minus minus 2, that is m plus 2 is equal to 0. So this will give me basically m into m plus 2 is equal to 0, right? And so this will give me the auxiliary equation, that is m square plus 2m is equal to 0. So what is the corresponding differential equation? For m square we write y double dash, for m we write y dash, so I got y double dash plus 2y dash is equal to 0. There is no constant term, so there is no y term. So this is the differential equation which is in this form. Now the third part is also very interesting. So can you pause the video and try the third part yourself? I am going to answer it. So the third part is very interesting, and I hope you can you must have guessed it. So the solutions are given e to the power 2x and x e to the power 2x. So if you remember, when I was getting this kind of solution, suppose I take the roots like m and m. So in that case I was writing the general solution as y is equal to c1 plus c2x e to the power mx. So basically actually I was getting the solution c1 e to the power mx. So one of the solution was e to the power mx, and then c2 x e to the power mx. So another solution was x into e to the power mx. So when we are getting the solution like x into the e to the power mx, that is happening when the roots are repeated twice. and we want a second order differential equation, it means that these two solution will be there as a part of general solution if we have the roots like 2 comma 2, if the roots are repeated, right? So if the roots are 2 comma 2, then what will be the auxiliary equation? The auxiliary equation will be given by, so the auxiliary equation is m minus 2, and another factor should also be m minus 2 is equal to 0. So basically this is m square minus 4m plus 4 is equal to 0. So the differential equation will be what? The differential equation will be for m square we write y double dash, for m we write y dash, and then we have the constant term, so we write 4y is equal to 0. So this is the differential equation corresponding to this. Just for the sake of argument, if I take for example, if I take one more question and where it is written that it is not a second order differential equation, now I am writing in a different context. So suppose I say that the solutions are e to the power 2x, x e to the power 2x, and x square e to the power 2x. So if the solutions are like this, it is very clear that this solution will be there only if the roots are 2, 2 and 2, because if the roots are 2, 2 and 2, the general solution will look like what? C1 plus C2x plus C2x square and e to the power 2x. So you can see that this will give me the solution like C1 e to the power 2x, C2x e to the power 2x, so x e to the power 2x will be a part of the solution, and x square e to the power 2x, so that will also be the part of the solution. Okay, so I hope given any such problem you will be able to solve. Now we are already like more than 55 minutes in the video, but I just want to complete this question, and this is even more important and interesting, so be very careful. Now in this question they are asking you to find a homogeneous linear differential equation with a real constant coefficient of lowest order which has the following particular solution. Now it is slightly different than the previous problem. Let me take it one by one. So it has the following particular solution, means solution is 5 e to the power x plus 2 e to the power 3x. Now what do you think, under what situation or for what kind of general solution we can have this kind of particular solution? So there are three terms in this, right? Sorry, there are three terms in this. It means what? That in the general solution we certainly should have something like c1 e to the power m1x plus c2 e to the power m2x plus c3 e to the power m3x, and because this is a particular solution, so there must be some condition over the general solution. And if I solve it, suppose I get c1 is equal to 5, and one of the roots m1 is basically equal to 0, and I get c2 is equal to 1 and m2 is equal to 1, and suppose I take c3 is equal to 2 and m3 is equal to 3. So in that case this solution will become what? This solution will become 5 e to the power m1x 0, then c2 will be 1, and e to the power m2x means e to the power x, and c3 will be 2, and then e to the power 3x. So if this is a general solution, then this may be a particular solution. Now just for the sake of argument, some of you may also think that it is also possible that suppose I add one more term, I add c4 e to the power m4x, and in that case suppose I take c4 is equal to 0. So if I take c4 is equal to 0, this term will become 0 for any value of m4. M4 may be any fourth root, but if the c4 becomes 0, then also the particular solution will look like this. But in the question they have used the term what is the lowest order differential equation. So the lowest order differential equation must be of order 3, because we have 3 terms in its particular solution, and those 3 terms can be seen as a situation where one of the root is 0, so there is just a constant term, and then one of the root is 1 and another root is 3. So if we have to form the differential equation, the roots should be equal to 0, 1 and 3. So what will be the auxiliary equation in that case? The auxiliary equation in that case will be m minus 0 into m minus 1 into m minus 3 is equal to 0. So this will give me what? This will give me m into m square minus m minus 3m plus 3 is equal to 0. So this will give me what? This will give me m into m square minus 4m plus 3 is equal to 0. And finally it will give me m cube minus 4m square plus 3m is equal to 0. So if this is the auxiliary equation, what will be the corresponding differential equation? That will be y triple dash, because third order derivative, minus 4y double dash and plus 3y dash is equal to 0. There is no constant term, so there is no y term. Okay, so this is how we have got the lowest order linear differential equation. Okay, now let us move to the B part. So if I have to solve the B part, let me change this color B. So the solution is like e to the power, particular solution is e to the power minus x cos 5x and 3 sin 5x. And one thing I think you are smart enough to understand, that if the particular solution is containing cos 5x term and sin 5x term, it means what? That the roots of the auxiliary equation must be complex roots, right? So if cos 5x is there but it is not multiplied by any because if you see, if the roots are like alpha plus minus I beta, you write the solution like what? You write e to the power alpha x and c1 cos beta x plus c2 sin beta x. So if you look at this part, here you can see that c2 is coming to be 3, c1 is coming to be 1, right? If you compare, beta is coming to be 5, but there is no e to the power alpha term. So in that case, alpha should be equal to 0. So if you look at this part of the particular solution, this part of the particular solution corresponds because of the roots 0 plus minus 5i. So if the roots are 0 plus minus 5i, the general solution will be like c1 cos 5x plus c2 sin 5x. Yes or no? Because the first part, that is e to the power 0x, will be 1. And because it is particular solution, the c1 might have taken the value 1 and c2 might have taken the value 3. This is the list. Some of you can say that other terms can also be added where c3 and c4 and all other, but that is not the point. The point is that we want the lowest order, and the lowest order will be possible if I take the roots 0 plus minus 5i. So this is 1. But there is another term also, an e to the power minus x. So it is clearly because of the root, that is minus 1. So we have the roots like minus 1 and plus minus 5i. So what will be the auxiliary equation? The auxiliary equation will be minus 1, so it can be because of the factor m plus 1, and plus minus 5i. So the plus minus 5i will be the root if the factor is m square plus 25, that is equal to 0. So if you multiply this, you will get m cube plus 25m and plus m square plus 25 is equal to 0. So this is your auxiliary equation. So what will be your differential equation? So the differential equation will be for m cube, we write y triple dash third order derivative. Then we have m square term, so we write y second order derivative of y. Then we have m term, so 25 y dash, and then we have constant term, so we write 25 and y, that is equal to 0. So this is how the differential equation will look like corresponding to this particular solution. So let's go and solve the last problem. So how do you solve the last problem C? And I would suggest you to pause the video and think about it. So ladies and gentlemen, the last solution has the particular solution x square e to the power 2x plus 2 e to the power minus 2x. Are you clear now that if x square is coming, it means what? You can't directly write x square. When you write the general solution, you write first, if suppose there is just one root, you will write c1 e to the power mx. If there are two roots m and m, then you can write c1 plus c2x e to the power mx. So in that case, x into e to the power mx will come. If there are three roots of the same type, then you write c1 plus c2x and then you write c2x square e to the power mx. So if x square e to the power mx term is coming in the solution, it means that minimum there should be 3 roots. And what will be those 3 roots? Those 3 roots, because of this, should be equal to 2, 2 and 2. If you have only 2 roots, then at most x into e to the power 2x term can come, right? You can say that what if there are 4 roots, then also it is possible, but we are looking for the lowest order. And when we look at this term, it will occur only if the root is minus 2, right? So what is the differential equation that we are getting? We are getting, because of this factor I am getting m plus 2, and because of this factor I am getting m minus 2 cube is equal to 0. Now this is your auxiliary equation. Write your differential equation and let me know in the comment section, right? So I have left for you 2 things to answer. If you remember, one of the question I left earlier where you need to solve the find the constant c1 and c2. I think this was the problem. So, and this is the last problem that I am leaving. Make sure that you are answering this in the comment section. So this is a long video. If you have watched the previous video and this video completely, it will be like taking care of your unit 2 requirements, right? So if you have arrived till here, certainly you have a lot of patience and you are a very sincere person. So thanks for watching, and in case if you are coming across any student who is taking this course, you should share this with your friends also. If you are new and have not subscribed the channel, subscribe it, because that is the only way for me to reach to the more number of audience and get motivated and solve upload other kind of videos also, right? So that's all from my side. Thanks for watching and have a very great day.